In section 2.2, here we're going to be solving some equations that have a higher power. We can still use some of our prior knowledge to help us figure out what these are going to look like. So when we start off with example A here, we need to sketch a graph of this quartic function. That's something that has a degree of 4. If you look in the back flap of your book, you'll notice that it has its parent graph looks very similar to the quadratic. It's just a little bit flatter at the origin. So when you graph this, if we remember our transformations, this minus 5 here, that means, or this 5 there, means that we're going to have a shift, and I need a different shape here. We're going to have a shift to the left of 5. So if we write that out, I always like to write that out because that kind of helps remind me of what I'm doing. So shift left 5. So that means that if we were to originally start at our origin here in the middle, then we're actually going to be shifting a little bit to the left, and we're going to be starting at a negative 5. So this will be the very middle of our graph. Now to find the other points, all we need to do is we need to just make a table of values, and then we make our table of values. We need to put the negative 5 in the middle and then surround that value. So x, f of x. So if we plug negative 5 in the middle, then we're going to go negative 6, negative 7, negative 4, and negative 3. So when you plug that 5 in there, you're going to end up with a 0. So we already plotted that point. If you plug a negative 6 in there, you get negative 1 to the 4th, which means that negative 1 to the 4th is going to end up being a positive 1. So if we go back 6, up 1. And we can actually do the same thing with negative 4. Plug a negative 4 in, add 5 to that, you get a 1 to the 4th, which is just 1. So we'll plot to that point. And then if you plug a negative 7 in, what is going to happen is you're going to end up with a 16. Same thing with a negative 3. So the 16 would be off your graph somewhere up around in here or over here. So when you plot this graph, what you need to do is you need to make sure that your graph goes up and it doesn't cross where x equals negative 3, and you make sure it goes up the other direction. Make sure it doesn't cross where x equals a negative 7, because if you do that, then your graph is going to look a little bit improportional and it's not going to be correct. So make sure that your graph does not cross this line right here, or it doesn't cross this line if those points are not actually in the square. Now the same thing can be done for example B, where if we look at this, notice we have a shift. We're going to go to the right 3, and we also have a vertical shrink by 1/4. So that means our graph is going to be kind of squished down and looking like it's going to be a little bit wider than what it really is. So let's make a table of values. And since we have that shift to the right 3, then that means that we're going to go through 0, 0, because if we remember your original parent function of an x to the 3rd, well, that graph is coming through something like this. It looks something a little bit like that. So this whole graph is going to be shifted to the right 3. So we're going to put a little point right here, because it's also going to be shrunk, but you can't really shrink a 0. So let me get rid of our parent function here. So what we want to do next is we want to plug all these values, or we want to plug some values into our table. So if we start at 3, we're going to surround that with 4, 5, 2, and 1. And we already said if we plug a 3 in there, we're going to end up with a 0. So let's plug 0 in. So we have the point over 3 up 0. Plug plug a 4 in, you get 4 minus 3 is 1, 1 to the third is 1, times 1/4 is 1/4, so you go over 4 up 1/4. Whoa, that's not the right spot. It's kind of hard to write these here. So we go to the right, 4 up a fourth. Same thing with the 2. If you plug that in, you're going to get a -1. -1 to the third ends up and becomes a -1, so -1/4. So plug that in. And then if you plug a 1 or a 5 in there, you're going to get 8, because you're going to take 2 to the third, which is 8, times 1/4, which is 2. So you go over 5 up 2. And you're going to get a -2 when you plug in a 1. So we're going to go to the right one, down 2. So if we plot these points, and you can plot more points if you like to get a little bit better graph, but there's your function for 1b.